evaluating functions. To evaluate something is basically just to solve the function, just to solve something. Evaluating functions can be compared to a machine, where each input, x, in the machine follows a rule to produce its output called the f of x. Two machine functions are given below. Use the given input values and function rule to find the output values. The output values are also known as y. But for this one right here, the rule is whatever x is, whatever the input value is, we have to multiply it by 2 to get the output. So if we multiply 2 times 5, okay, we take the input 5 and we multiply it by 2, we're going to get an output of 10. Now if we take the input of negative 3 and multiply it by 2, we're going to get an output of negative 6. Okay, now let's go to the other machine or the other function here. And if we take an input, we have to square that input, multiply it by itself, and then add 1 to it to get an output. So our input is 5. If we take 5 and we multiply it by itself, 5 squared is 25. 25 plus 1 will give us 26. So we're just running the input through the machine to get a certain output. I like to think of a function as being like a blender. We take the ingredients, the input, we blend it up in the machine, and we get a certain output, the juice or the smoothie. Negative 3 is input. Negative 3 times itself gives us positive 9. Positive 9 plus 1 gives us 10. Moving on down here. For function notation, f is the name of the function. F of x is read as f of x and is equal to y. So this is the output. The output is going to be y. X is the input value. And looking over here, write each of the rules from the function machines above using function notation. Okay, so looking at machine A or function A, we can say that the rule is the f of x, the function of x, is 2 times x. And for machine B, we can say that the function of x, the f of x, is equal to x squared plus 1. Okay, that's what they mean by function notation. F of x equals whatever the machine does here, whatever that blender does. 2 times x, or x squared plus 1. F of x equals whatever the machine does to the function. To evaluate f of x equals 3x plus 9 for x equals 5, substitute 5 for the variable x and write f of 5 equals 3 times 5 plus 9. Therefore, f of 5 equals, okay, let's put 5 in here, and 5 times 3 gives us 15. 15 plus 9 gives us 24. Let's look down at the bottom 3 examples. Evaluate the following functions. Okay, f of x equals 6 times the quantity x plus 9. So if we input 4 for x, we get 4 plus 9 times 6. 4 plus 9 is 13. 6 times 13 gives us 78, I believe. Let me just do that right here. Yeah, 78. So f of 4 equals 78. And what if f equals negative 6? Let me cross this out. Let me cross that out. If f equals negative 6, we have 6 times negative 6 plus 9. Negative 6 plus 9 gives us 3. 3 times 6 gives us 18. F of negative 6 equals 18. Let's do a few more here. we're going to substitute a 1 for x right here, and we're going to get 1 squared is 1. 1 minus 12 gives us negative 11. If the g of x equals negative 3, we could put in a negative 3 here. So negative 3 times negative 3 gives us positive 9. Positive 9 minus 12 gives us negative 3. Yep. Negative 3. And last example, p of negative 8. We could put in a negative 8 here. Let me go ahead and write that down. Go from negative 8. So this becomes 8 plus positive 8. 16 over negative 8 gives us negative 2. Let me cross this out. Don't need that anymore. P of positive 8, and we get 8 minus 8 over 8. So 8 minus 8 is 0. 0 divided by 8 equals 0. And that's it for evaluating these functions here. The last question, for p of x in question number 3, is there a value of x where the function cannot be evaluated? Explain. Okay, is there any number we could put in for x where the function can't be solved at all? Is there any number we could put in there? Let me let you think about it for a couple seconds. What could we substitute for x where we can't solve this function at all? Okay, I'll go ahead and say the answer. If x equaled 0, the function could not be evaluated. Okay. And why is that? Because we can't divide any number by 0. Any number divided by 0 is undefined. So we can't use 0 as an input in this case for number 3. Okay, moving over to the back part of this. Okay, if f of 3, well, for f of 3, if we input 3 for x, we would get, let's say that f of 3 equals 1/2 times 3 minus 6 minus 5 halves. Okay, let's break down our parentheses first. 3 minus 6 gives us negative 3. So we got 1/2 times negative 3 minus 5 squared. So what's 1/2 times negative 3? That's negative 3/2. Excuse me if I'm running out of space here. Negative 3/2 minus 5/2. What's a negative 3 minus 5? That gives us negative 8. Negative 8/2 equals negative 4. So our final answer here is f of 3 equals negative 4. Okay, and last one. Given h of x equals 5 times the quantity x plus 3 squared, what is the value of h to the negative 5? What is the value of h of negative 5, excuse me? So if we put in negative 5 here, we get h of negative 5 equals 5 times negative 5 plus 3. Negative 5 plus 3 gives us negative 2. And now negative 2 squared gives us 4. So we got 5 times 4. And 5 times 4 is 20. So our final answer is h of negative 5 equals 20. Okay, so that's all I'm going to go through, but if you have any questions in class, as always, just let me know. I'll work on it with you, okay, one-to-one. And good luck to you. Thank you.